Hi, boys and girls. We have finished Unit 1 of our No Atoms Science Unit, Matter and Energy. So I wanted to make this video for you as a little review to help you prepare for our science test, which is Friday, October 21st. So we have this week to reread our science student reader, to look through our science notebook and the 2 labs that we performed, and you can watch this video. So these are all strategies and tools and references that you can use to prepare for the test on Friday. Now I'm going to recommend, there are a lot of videos in this little YouTube presentation. You're going to need to stop this video to watch the other videos. Some are short, some are 3 minutes, 5 minutes, 10 minutes, and some are a little long, like they're 22 minutes. So plan your week to do a little bit of this, don't do the jumping jacks, to do this video throughout the week. You have Monday, Tuesday, Wednesday, Thursday. You have 4 nights to do this. So do a little bit each night. So first we're going to look at the goals of this unit. And this is what we teachers look at to make sure that we are focused and making sure that you're learning what you need to know. And the goals were to describe how matter is made up of atoms, and the number and kind of atoms that make up a substance determines its properties. We did talk about the properties of matter. We talked about the properties of the sand and gravel and other items in our classroom, and we could describe them using our senses or with tools to measure them. We observed how unbalanced forces caused movement. That was with our marble speed and collision experiment, and how moving objects have energy and how energy transfers in a collision. And we talked about forms of energy and how energy is transferred. So the vocabulary that we used during this unit was atom. We talked, and you built atoms last year. Cause and effect, how one thing causes another thing to happen. Energy, force, friction, gravity, mass, matter, pattern, property, scale, science, scientific method, speed, volume, weight, and work. Now I did that quickly because now we're going to dig a little deeper. So what you learned last year when you built the atoms was it's the smallest piece of matter that has the properties of an element. It's a combination of 3 subatomic particles, protons, neutrons, and electrons. You remember making that with a little styrofoam half sphere, and you made those last year in 3rd grade. So this is an atom video from Bill Nye the Science Guy. This is 22 minutes long, but it does really explain about atoms in a much deeper way, so you should watch that. Cause and effect. This is something that you know. It's the relationship between events and what happens because of that event. So for instance, her shoelace is untied, so she's going to trip. So these things happen all the time with all of us. And so we learned that cause and effect with our marble speed and collisions. Energy is the ability to do work. And we have a video here. These 2 children, it's made in India, so they have a little bit of an accent, but it's a great video to explain what energy is. And it's the ability to do work. And I also found a Schoolhouse Rock energy video. In Schoolhouse Rock, when I was a kid, they used to show these short videos between programs, kind of like a commercial, but they were educational. So it's not that long, but it's kind of cute. It has a song, and it tells you about energy. A force is a push or a pull that you do to an object, and it changes its speed, its direction, or its shape. So you can probably figure out if you push something, you're forcing it in one direction. If you're pulling it, you're pulling it and forcing it into another direction. And when a force acts on an object, it changes its speed or direction. So the bigger the force, the more the object moves. So if this person is really strong and is pushing, will this move faster? Yes. If this person is not as strong and is pushing slowly and isn't pushing as hard, the object will move more slowly. So that kind of makes sense when you think about it. Friction. Oh, look. Can you rub your hands together? And it's a force that slows the motion when two objects rub together. And the mechanical energy is transferred into heat energy. So the mechanical energy is the rubbing, and it's creating heat energy. When you put the brakes on a bike, you're pushing, you're using a force, mechanical energy, and it stops, the friction stops you. Okay. And I found another Bill Nye video about friction. And again, Bill Nye, it's a 30-minute program on TV with commercials, so it's about 22 minutes long. Gravity, it's the force of attraction between all matter. And we talked about gravitational energy when we did our marble speed and collisions, because the reason we just released our marble, because the gravitational energy, the gravitational force, was making the marble roll down the piece of foam. So it's the force of attraction. It's how things are pulled together. It's why we don't float around. We massed our sand and gravel using our digital scales. And the mass is a measure of the amount of atoms that make up an object. So we also used our pan balances to compare the mass of objects. We put paper clips on one side of our pan balance and gram pieces on the other side to see how many paper clips it took to be 10 grams or 20 grams or 5 grams or 1 gram. So we did that. And this is just showing that this is not weight. Because on Earth, the dog has a certain mass, and it's the same on the moon. Its weight would be different because the gravitational force on the Earth is different than the moon. So while these are the same, its weight would be different. And matter is everything. Everything that has mass and takes up space is matter. So we have our matter song that we like with Mr. Edmonds. You've watched that. And this is a little video on matter. So this is about 3 minutes. This is about 3 minutes. And we have our states of matter, solid, liquid, gas. Okay. A pattern is something that happens in a regular and repeated way. We talked about this. Accident, incident, pattern. If something happens once, it could be an accident. If something happens twice, it can be an incident. Like you kind of wonder, And the third time it happens, it's a pattern because it's something that happens in a regular and repeated way. And I think last year you learned about, in third grade, the phases of the moon. And that's the pattern. When we talked about mass and matter, we talked about the properties of matter. And we can look at objects and we can observe them and talk about their characteristics. For instance, for this ball, it's round, it smells like rubber, it's solid, it's bouncy. So that's how you could describe this ball. You can also measure it. You could find its mass. You could put a tape measure around it and see its circumference. So you can measure the characteristics or you can observe the characteristics. For instance, with sand and gravel, when we started, we observed their characteristics and then we measured their mass with the digital scale. So this is a video on properties of matter. This one's a little longer, and this is about 3 minutes on properties of matter. So you can watch those. And so this is a little practice. What are the properties of this object? Well, this is a pencil, obviously. But how would you describe it to somebody if they could not see it? So basically, when you're describing the properties of an object, it's as if somebody was not looking at the pencil. How would you describe a pencil to somebody? The color, the shape, you would have to describe the eraser, the point. And could you maybe use a ruler to measure how long it is? So those are all properties. What are the properties of this apple? If somebody didn't know you had an apple, how would you describe it? And as you can see, they do have the apple on a digital scale because that's a measurable property. So what you observe through your senses, sight, smell, hearing, tasting, touching, Those are observable properties. Measurable properties are like the digital scale, or again, you could put a tape measure around it. What are the properties of this test tube? Like we call it a graduated cylinder. How would you describe this? Because you may not have known what it was, but it does measure liquid. It has, it measures from 0 to 25 milliliters. It is a cylinder, and it looks like it's clear. What are the properties of this crayon? How would you describe that to somebody? And they gave you a ruler because that's a measurable property. But how would you describe it, what it looks like, and what it does? So a scale is not a scale that measures, but this scale is the relative, the relationship between the real size of something and the size of a map, model, or diagram. And we're going to talk about map scale, because obviously if you have a map of, say, North Reading, it can't be the size of actually North Reading. It has to fit on a piece of paper. So that's its scale. How many inches equal a mile? So obviously, if you're doing the solar system, you have to make it fit on a page. So that's not the actual size. So that's what scale means. And science, well, that's new knowledge that we can get from experiments, right? And the role of a scientist is to ask questions and then perform experiments to get information. And we have used the scientific method twice now for our 2 different experiments, massing sand and gravel and marble speed and collisions. So we started with a question that we wanted to ask and find out. We did research because we wanted to know if people had already done these experiments or have different information or what we already know, and then formed a hypothesis. We answered the question with this research, with our knowledge. We performed the experiment to test the hypothesis, and we wrote down a summary of the experiment. We listed the materials and the procedure. We drew a scientific diagram. Then we had a data table of some sort. We actually had a graph for the marble speed and collisions, and then wrote a conclusion to summarize, was our hypothesis proved true or false? And we used the data to back that up. And here's a scientific method song to practice the steps of the scientific method. Speed is the rate at which an object covers the distance. So how fast you can cover from one spot to another. And we had fast, medium, and slow for our marble speed and collision experiment. And volume is how much space an object takes up. So for instance, in this graduated cylinder, this tells us how much volume this water takes up, and it's 45 milliliters. It can also be for a 3-dimensional shape, how much space it takes up. We have a conservation of energy song, and it says that energy cannot be created or destroyed. It just always is, and it has the forms of energy also. So this is a cute song. It's about 5 minutes long. And then we learned about different forms of energy. First, you can have potential and kinetic energy. Any single form of energy can be potential or kinetic. And we talked about this. If a bike is at the top of the hill, that has potential energy. And then once the bike is going down the hill, that is kinetic. So this is a short video to explain potential and then kinetic, what is actually happening. And this is a video about the different forms of energy and how they can transfer from one to another. Weight is how much the force of gravity pulls. Oh, this is the typo. Pulls. Whoops. Pulls. Oh, why is it doing that? Pulls on an object or substance. And it's measured in Newton. Sometimes. Obviously, when we measure weight, it's pounds, ounces, grams, kilograms. But when they're talking about the force of gravity in larger objects, it's in newtons. But it's how gravity is pulling against an object. And work is any change in position, speed, or state of matter due to a force. So this is a video about force, work, and energy, and as is this. So there are 2 little videos to explain that because we said a force pushes or pulls against an object, so the work is what is doing that. The work is creating that force, it's creating energy. So these videos explain that as well. And that's our unit in a nutshell. And I know I went through it quickly, but I did put a bunch of videos in here for you to watch, and I suggest that you do that. And you have tonight, Monday, Tuesday, Wednesday, and Thursday. So you have 4 nights to watch all these videos, to preview this, to look through your science notebook, to look through your science student reader, and to just take your time. And if you have any questions, please ask me. You have the whole week, okay? And the test is Friday. So that is your YouTube video to practice for the No Atom Unit 1 Matter and Energy. Well, I guess you could do shoulder raises to raise your shoulder to your ear and hold it. Okay?